You know, for decades, we've been promised these super intelligent robots, right? But the reality, well, it's often been a bit clumsy, a little limited, but that is all about to change. Today, we're going to dive into the absolute revolution that is robot learning and the incredible platform at the heart of it all, NVIDIA's IsaacLab.
So why do robots so often seem, well, clumsy? I mean, we've all seen those videos, right? A robot doing something amazing in a factory, but then you see another one totally failing to, pick up a cup in the real world. So what gives? What's the disconnect? Well, it's not the hardware. The problem is how we've been teaching them to think.
Okay, so think of it like this, a tale of two robots. On one hand, you have traditional programming. This is like giving the robot a perfect, super detailed map. And hey, it works flawlessly as long as the world looks exactly like that map. But the second you throw in an unexpected obstacle, a chair that's been moved, the whole thing falls apart. Now, the new way, robot learning, it basically throws that map in the trash. Instead, it teaches the robot how to read the terrain for itself. It learns, it adapts, all by actually interacting with the world around it.
And this brings us to the robot learning revolution. I mean, this shift from just rigidly following a set of instructions to actually genuinely learning from experience, it's huge. It's not just an upgrade. It's a total reimagining of how we build intelligent machines from the ground up.
So what is robot learning really? Well, at its core, it's all about swapping out tedious manual programming for autonomous experience. So instead of some core engineer trying to code for every single possible thing that could ever happen, the robot just learns for itself. It tries something, it fails, it tries again, it succeeds, and it gets a little bit smarter every single time. Honestly, a lot like how we learn, right?
And the advantages here are pretty incredible. You get autonomy, so the robot can operate with way less human handholding. You get adaptability, so it can handle new situations. Efficiency, of course, because you're not spending ages programming every little thing. But the real game changer, the big one, is generalization. I mean, imagine this. You teach a robot how to pick up a cardboard box, and from that, it just knows how to pick up a delicate glass bottle or a weirdly shaped wrench it's never ever seen before. That's the kind of power we're talking about unlocking here.
Okay, so let's get into why this is all happening now. The idea of robot learning isn't brand new. So what's changed? What's the secret sauce? Well, it turns out there are two key ingredients that have finally come together to make this revolution actually possible.
First up, and this is a big one, we now have access to near-infinite data. You see, AI models, they just gobble up data. And for a robot, the best kind of data is experience. Thanks to these incredibly realistic physics simulators, we can give a single AI agent the equivalent of, get this, millions of years of practice in just a couple of hours. That's a scale that is it's literally impossible to do in the real world.
And the second driver? Well, you need an engine to process all that data, right? And that's where powerful GPU computing comes in. We're talking about the same kinds of chips that power the most amazing video games and massive AI models. They give us the raw horsepower we need to run these super complex learning algorithms, letting those virtual robots process all that experience and turn it into actual intelligent skills. All right, so we've got the two key ingredients: near-infinite data from simulations and the massive computing power of GPUs. But you need a place to bring it all together, right? You need a workshop. And that, my friends, is exactly the role of NVIDIA's IsaacLab. It's the unified platform, the proving ground built for this new era of robotics. Now, what's really important to get here is that IsaacLab isn't just some standalone tool you download. No, it's deeply, deeply woven into the entire Isaac Sim ecosystem. And that seamless integration is what gives developers this incredibly powerful pipeline from building a hyper-realistic virtual world to training a super smart robot inside of it, all in one place. It's the whole shebang. And look, this isn't some version 1.0 product that just came out of nowhere. IsaacLab is actually the culmination of years and years of research. It's built on the foundations of earlier NVIDIA frameworks, unifying the best of both worlds. You get the broad, flexible capabilities of research tools like OIGE, combined with the super performance-focused design of frameworks like Orbit. The result is a mature, battle-tested platform that's ready for some really cutting-edge robotics.
So, let's peek inside the lab. What does this platform actually give you? Let's break down the core features that make it so powerful for both researchers and developers.
Okay, so first off, IsaacLab is built for speed. It supports a huge range of learning algorithms, so researchers have tons of flexibility. It also comes with a whole library of predefined robots and environments. This is awesome because it means developers are not starting from a blank page. But maybe most importantly, it's built for massive scale. We're talking thousands of simulations running all at once, in parallel. And to top it all off, you get these great visualization tools so you can actually see how your robot is learning, which makes it so much easier to figure out what's working and what's not.
Now, one of the core ways these robots learn is through something called reinforcement learning. And honestly, the concept is super intuitive. Just think about how you'd teach a dog a new trick. When the dog does the right thing, what do? You give it a treat, a reward. When it messes up, it gets nothing. Over time, the dog figures out which actions get it the treat. It's the exact same idea for a robot in IsaacLab, except the treat is just a positive number, a score for doing the task right.
All right, this is where the rubber meets the road. From sim to real. How in the world do you take a robot that's learned something perfectly inside a computer and transfer all that intelligence to a physical machine out here in the real world?
Well, the workflow is actually this really clean three-step process. Step 1. Developers generate just massive amounts of training data inside IsaacSim. Step 2. They use a simple Python API to define what the robot's world looks like and what its goal is. And finally, Step 3. They use powerful training libraries, like NVIDIA's own RSL-RL, to kick off that reinforcement learning process. And the robot just trains and trains until it nails the new skill.
And really, this whole process, every part of it, is engineered to solve the single biggest challenge in all of robotics, bridging that sim-to-real gap. The whole goal is to make sure the intelligence that a robot learns in a perfect digital world can actually survive contact with our messy, unpredictable physical one.
So what we're seeing here is this monumental shift from robots that are just programmed to robots that learn. And platforms like IsaacLab, well, they're the workshops where this future is being built, piece by piece. They're laying the foundation for machines that don't just follow our commands, but can actually problem solve on their own. And that leaves us with a really big question to think about. When a robot can learn a new skill as easily as you or I can download an app, how is that going to change not just industry, but our everyday lives?